The diagram shows the graph of f of x. Find the unknown coefficients a, b, c, d, and e. So we can see that it is given 2 points and 2 vertical asymptotes. Let's use given information to make some equations, and then we'll just solve the obtained equations to find the unknown coefficients. So let's consider 0 and 5 over 4, just substituting 0 for x and 5 over 4 for y. It's also y-intercept. So we get the next, that 5 over 4 is what? B over E. Next, let's consider the next point. It's a root or x-intercept, and it's when what? Y is 0, when x is negative 5 over 2, but function is a fraction, and fraction is equal to 0 when numerator is equal to 0, but denominator cannot be equal to 0. So ax plus b must be 0 when x is negative 5 over 2. So 0 is negative 5 over 2 a plus b. And we know that the vertical asymptote arises when there is division by 0. It means that when x is negative 4, denominator is 0. So you may just substitute negative 4 for x and equate it to 0, then negative 1 for x and also equate to 0, and get two equations, two additional equations. But I want to use sum and product rule, and for usual quadratic ax squared plus bx plus c to be equal to 0, we know that the sum of roots is negative b over a and product is c over a. So here it becomes sum is negative 5 and sum is negative d over c, and product is 4 is what? It's e over c, and we get what? 1, 2, 3, 4 equations, but there are 5 unknown coefficients, and we know that to find 5 unknown coefficients there must be what? 5 equations to get the exact answers. So it seems that it's not enough information, and it's a bit tricky question, but we can notice the next. We can represent all coefficients in terms of c. So you can see that E is 4c, D is 5c, B is 5 over 4e, and E is 4c, so it's 5c, and A is what? 2 over 5b, and B is 5c, so it's 2c. And if we substitute for A, B, C, D, E, we get the next. It becomes A, it's 2cx plus BB is 5c, cx squared plus D is 5c, and plus E. You can see that C cancels. So this expression is independent of C. C may be absolutely any value. So we get finally 2x plus 5 divided by x squared plus 5x plus 4. So A is 2, B is 5, C is 1, D is 5, and E is 4. The next, find the intervals for which derivative is less than 0. We know that where derivative is less than 0, it implies what? Function is decreasing. When derivative is greater than 0, function is increasing. Derivative is equal to 0, it's a stationary point with horizontal tangent. It may be maximum, minimum, or neither, or just point of inflection. Neither, I mean no maximum, no minimum. So we can answered directly from the graph. So we can see that here function is decreasing, here is also decreasing, decreasing, decreasing. So function is decreasing everywhere. But we should always exclude x values where there is division by 0, because function is undefined at -1, -1. So the answer is x is what? Less than -4, or not and but or. X is greater than -4 and less than -1. We use strictly less or greater, and in such way we exclude -4 and -1, or x is greater than -1. Or you may consider derivative and consider an inequality and just solve an inequality. The next proves that -5/(0) is a point of inflection. The necessary condition is that the second derivative must be 0 at this point, and also we should show that the second derivative changes sign passing through at this point, or it's also acceptable to show that the third derivative at -5/(2) is not 0. At -5/(2) it's also acceptable. Or consider the second derivative at point a bit left and the point a bit right, and show that second derivative changes sign. So we need to find the second derivative. And function looks like what? Division, so we should apply what? Quotient rule. And it says what? It becomes denominator squared, numerator derivative multiplied by just denominator, minus numerator multiplied by denominator derivative, which is 2x plus 5, so it becomes 2x plus 5 squared. And let's expand and simplify. So it becomes 2x squared plus 10x plus 8 minus 4x squared minus 20x minus 25, and it becomes negative 2x squared minus 10x and minus 17 divided by x squared plus 5x plus 4 squared. And for this question you may consider it to be strictly less than 0. You can see the denominator is always positive, and it's what? It's concave down parabola. And if you find vertex and you need y coordinate over vertex, and since it's concave down parabola and y value over vertex gives us what? Maximum possible value of function, and when y is negative, hence all possible y values or range of this function is less than 0, and that's why for all values, x values, derivative is less than 0, and you remember that you should exclude x values which give division by 0. So let's continue to find the second derivative. It's also quotient rule, so it becomes denominator to the again squared, so squared, so it's to the power of 4, and numerator derivative, so it's what? Negative 4x minus 10, and by just denominator x squared plus 5x plus 4 squared minus, due to formula, just numerator we can factor out minus, so it becomes plus 2x squared plus 10x plus 17. Yes, and multiplied by denominator derivative, and it's this squared, and it's chain rule. Something squared, it's 2 times something derivative, so it becomes 2 times x squared plus 5x plus 4 and multiplied by what? X squared plus 5x plus 4 derivative, which is what? 2x plus 5. And first of all, we can definitely factor out firstly and then equate it to 0, because we can notice that it becomes denominator to the power of 4, but you can notice that this and this can be factored out. Just a moment. If we factor out with minus 4x minus 10, it becomes x squared plus 5x plus 4 squared, but minus 2x squared plus 10x plus 17 times x squared plus 5x plus 4. And also no, we factor out, so let's check. Yes, and also we can see that we can factor out what? X squared plus 5x plus 4 so that it becomes x squared x squared plus 5x plus 4 minus this, but minus in front, so let's expand, minus 2x squared minus 10x minus 17. So it becomes negative 4x minus 10. And notice that we will not find point or points of inflection. We will just check or prove that this is a point of inflection. So we need substitute this for the second derivative and show that it's a second derivative is 0, and actually it's already can be shown because this will be 0. And we need to show that second derivative changes sign, or in general maybe consider the third derivative, and the third derivative at that point is not equal to 0. But let's continue and simplify. So it's negative x squared minus 5x and what? Minus 13. We can factor out minus, and there will be also plus, or also factor out minus. It's not necessary, but power of 4 and over x squared plus 5x plus 4 to the power of 4. Yes, and let's consider the second derivative at negative 5 over 2, and you can see that it becomes 4 times 5 over 2 with minus plus 10 times something, so it's 0, so it becomes 0. So definitely it's 0. If you want or try to find point or points of inflection, you should equate it to 0 and solve. And again, fraction is equal to 0 when numerator is equal to 0, or actually it can be we can cancel this and it becomes cubed in general. But if you don't do that, you cannot take these zeros, because what -1 and -4 are zeros of the denominator, so you cannot consider x is -1 and x is -4. We can simplify. And let's check, it's interesting. It seems that discriminant is negative. Discriminant is what? b squared minus 4ac. Yes, and you can see the discriminant is negative, and there are no another roots of second derivative to be 0. But I repeat that we prove that a point is a point of inflection, so we can just substitute into second and just show that second derivative is 0. So, but it's not enough, and let's consider a point a bit left. It's what? It's -2.5, so let it be -3 and -1.5. -0.5, and I don't want to substitute it. And notice that if you keep this to be to the power of 4 and you keep this term, you may you can ignore denominator. Why? Because to the power of 4 is always positive, so it doesn't influence into sign. So you may consider only this, or using a calculator. Using a calculator, you can find the second derivative, the value of the second derivative at the point to the left, and I can see from a graph that it must be to the left. You can see it's concave up, to the right concave down, so this value must be positive and this must be negative. And since at x is negative 5/2, second derivative is 0 and changes sign, it doesn't matter from plus to minus or from minus to plus, and second derivative changes sign, and that's why at -5/2 it's a point of inflection. And the last question, prove, yeah, it's done. Find the intervals for which second derivative is greater than 0. And again, in general, you may consider an inequality, second derivative to be greater than 0. And if you consider it to be to the power of 4, it doesn't influence for sign, because it's always positive. So you may consider numerator only. Or if it's if a question is with a calculator, you may use a calculator, but here we can give the answer directly from the graph, because we know that second derivative to be positive, it implies what function is concave up. Here it's a form, it's concave down, and it's concave up, and also this part is also concave up. So function is concave up for x is greater than -4 strictly and less than -5/2. It's point of inflection, so I also exclude it. and not and, you must write or, because we just add intervals, and it implies intersection at the same time, or x is greater than -1. And that's all for this question.